Hello, welcome to our new video. If the things I show you in this video don't make you at least 5 times more productive, I'm asking you to dislike this video, close this tab, and never listen to any of my advice again. But if they do, let me know in the comment section, like this video, and share it with somebody who needs it. Today, we're doing some real stuff. All of you most likely heard about AI automations, harness engineering, agentic workflows, and a bunch of these big words. Everyone uses them, everyone talks about them, and nobody actually shows you what all of this really means and how to do it. And by the way, this video is not only for developers, this is for everyone who wants to see how to use AI in the best way possible. I want to show you something that will totally change how you look at AI and how you'll work in the future. Because AI is way more than a chat window, and I'll show you exactly what it means to set AI up so it does the work for you. Step by step, we'll prepare everything for your first harness engineering lab, and you'll do this stuff better than 99% of the people that use AI today. Some of the things here, even most developers still don't use. Okay, first thing first, set up a code editor on your machine. You don't have to be a developer to use a code editor. I understand we have so many apps and Chrome extensions and stuff out there, but from now on, you won't depend on anyone. I won't explain how to install a code editor. Just follow the instructions on the official page. It takes a few minutes. I recommend Cursor or VS Code, but every other editor is pretty much the same thing. Before we define harness engineering, let me define one word I'll use all the time, the agent. When I say agent, I mean an AI like Claude or GPT that doesn't just answer your questions in a chat. An agent can also open your files, write code, run commands, and search the web. So that's the difference. A chat talks, an agent does stuff. And now, what is harness engineering? Harness engineering is the environment that you build around your agent. And that's it. So what does that environment look like? It lives in your code editor, and in most cases, it has three things: MD files, MCPs, and tools. You see, it's not as complex as everyone talks about it. Let me explain all three. MD files, these are regular markdown files, plain text files that agents read. There we store all the instructions for the agent on how to do stuff, and we have some common types that are used widely. Skills, files that teach the agent how to do something. Rules, files with predefined rules that the agent must always follow. And docs, files that describe the architecture of our project, which means how our project is built and how the parts connect. MCP. MCP is a protocol that connects apps with AI agents. It takes the app's endpoints and data and translates them into a language the agent understands. When the app connects, it immediately gives the agent a clear list of all the available tools and all the data it can work with. The agent reads this list and instantly knows exactly how to make requests to that app. In plain words, MCP is something in the middle between the app and the agent, and it works as a translator and instructor for your agent. Tools. Tools are very similar to MCPs, but these are our own coded functions, written in any programming language we choose. We can write our own scripts and functions, with AI of course, and explain to the agent how to use them. And we also have built-in tools. For example, Claude Code and Codex already come with their own tools that they use to read your files, edit them, or do a web search. But it's the same idea every time. The agent reads the function, figures out how to run it, and runs it. How to build your environment? MD files first. Use AI to create these files. Skills, rules, docs, name it. The best practice is to have one main coordinator file. That file is called agents.md or Claude.md. And these two are the same idea. Agents.md is the open standard that most tools read, Codex, Cursor, and many others. Claude.md is the same thing, just the name that Claude Code uses. Same job, different name. In that file, you set the base rules for your project, and you instruct your agent when to use which skill, rule, or doc. You can check our starter GitHub repository and the files inside of it as an example. The link is in the description of the video. Then MCPs, we use an MCP when we want our agent to work with an external app that supports this protocol. And after the setup, just with your prompt, you can tell the agent to talk with that app and bring back the response. And how to set this up. It looks like the tricky part, but it's actually the easiest thing here. For example, if we want to install the Chrome DevTools MCP, the one that controls the Chrome browser, we open our agent and we tell it, research how to install, configure, and use this MCP. The agent does all the work for you. After that, we just reload our editor window and we're done. And believe me, the Chrome DevTools MCP will be your best friend in the future. It can do pretty much everything that you do on a website: open pages, click around, check the full page structure and the HTML, watch the network requests, take screenshots, test stuff. With this MCP, you most likely won't need third-party Chrome extensions anymore. And one important thing, if the app you want to use doesn't have an MCP, no worries at all. The agent can still work with that app by writing its own scripts. Sometimes it takes a bit more time, but it's 100% doable. And tools. As we already said, tools are a very similar idea to MCPs, but we're the ones who create them and define the logic, the rules, and the instructions for them. We won't spend too much time here because you don't need custom tools to start with harness engineering. In the beginning, the built-in tools, the MD files, and the MCPs will cover almost everything. Do you believe me if I tell you this is enough to start? The core idea is very simple. Enable your agent to do stuff and explain how to do it. Once this is set up, every future task becomes smoother and more accurate. Now, before the tips, 3 things you need to know, because everything later builds on them. First, planning and execution are always separate. When you build with AI, you never plan and build in the same step. First, you create a file, for example, specs.md, and inside of it, you put everything the agent has to build as a list of items, and every item has a checkbox. The agent ticks a checkbox when the item is done, so it never gets confused about where it is. This way of working is called specs-driven development, and you're always free to tweak it so it fits you best. And here's something that maybe surprises you. I never use the agent's built-in plan mode. And the reason is simple. We already have a planning phase. It's the moment when we create the specs file. Plan mode keeps the plan inside of the chat. And when the chat is gone, the plan is gone with it. Our plan lives in a file inside of the project, and it stays there. Second, remember one name, the Ralph loop. Later in this video, I'll show you how to run your agent in a loop so it works on your project on its own, item by item. That pattern has a name, the Ralph loop. I'll explain it fully in the loop section, so for now, just remember the name. Third, your harness is a product. The environment you build will fail sometimes, and you'll debug it, version it, and upgrade it just like any other software. Keep that in your mind the whole time. We're not writing some notes on the side. We're building a real system, and we treat it like one. And one more thing before we start. If any term or concept in this video is not clear, ask your agent to explain it to you. And after that, you can even ask it to show you an example or to implement it for you. Tip number 1. You make the decisions. The agent does the typing. Your job is not to write code anymore. And honestly, it's also not to correct the agent line by line while it works. With all these AI tools, everyone is a developer now, but not everyone is an engineer. Your main job in this new world is the environment. You're the one who creates it, maintains it, improves it, and expands it, all the time under controlled conditions. You're the one with the judgment, what to build, how to verify it, and when the agent is wrong. And that gives us one very important rule. Never fix things quietly by hand without updating the instructions that allowed the mistake in the first place. Because if you only fix the code, the same mistake comes back tomorrow. But if you fix the instructions, it's gone for good. Tip number 2. Write detailed docs and cover everything. When you write the docs about your project, try to cover every single concept you have. The architecture, the technology, the patterns, the practices, the business logic, literally everything that you already established or plan to establish. Keep all of it in separate files and cross-link the files between each other. The more you describe your architecture, the safer you are from the agent drifting away and making silent mistakes. Because one wrongly written thing inside of your docs can cause hundreds of wrongly implemented items. That mistake compounds very, very fast. And the same logic applies to our code base as well. Later, when we run the Ralph loop on the project, this becomes even more important. Because if the loop runs on low quality code without strictly predefined rules, the quality of the code base drops rapidly. And one more thing about the docs, wherever possible, put an example of a correct implementation right inside the file. Tip number 3, point docs at live code, don't describe it. Here's a trick that saves you from 2 problems at once: docs that lie and wasted tokens. Never explain in your docs how a piece of code behaves. Instead, point at the file. So instead of writing 3 paragraphs about how we fetch our data from BigQuery, we write 1 line. The BigQuery data fetching lives in this service file. The code is always the truth, and the doc just shows where the truth lives. So the doc can never fall behind the code. And this same logic applies to the harness.md files themselves. Reference them by name everywhere because we'll use them all the time. Tip number 4, keep your main file under 100 lines. Your agents.md or Claude.md must stay small. Keep it under 100 lines. Never try to put everything into this one file with dozens of instructions inside, because when everything is important, nothing is important. Treat this file as a router, like a table of contents. It says which file the agent should open and when. This way you avoid a bloated prompt, confusion, and wasted tokens. This is the simplest trick in this whole video, and it saves you real money and real execution time. And treat all your other MD files the same way. When a file grows too big, break it into more files. Tip number 5, feed the agent the knowledge that lives outside the code. When we build an app or a website, most of the time there's a story behind it. A business model, conversations, decisions, data that never appears inside of the code base. That gap was always there, and now we're closing it. You can improve your harness a lot by providing this context around the project. So next to the project docs, we add custom MD files as an external knowledge base, static or dynamic. For example, annual-plan.md or pricing-plan.md. And now we can tell the agent in our instructions, always stay compliant with the pricing plan file. And we can go even further. We can take our Slack messages, our task items, our support tickets, pre-process them, and store them into our database. Then we just explain to the agent how to retrieve them, and now we can fix our tickets on the fly. And guess what? By doing that, we just built a custom tool, the exact thing we defined at the beginning of this video. Tip number 6, track your tech debt in its own file. When we build a real app, we make compromises all the time. Some of them look wrong from the outside, but they were made on purpose. For example, we use a different banner component on one page, even though we already have a reusable one on the other pages. These decisions are sometimes counterintuitive, but they had a reason. And later, nobody remembers anymore if something was a mistake or an intentional decision. That's what tech debt is, the compromises we collected on the way. And tech debt is not necessarily a bad thing, but it must be visible. So create and maintain a file called tech debt tracker and point your agents to it. This way, the compromises don't mix with your predefined architecture docs and rules. You get extra points if you also tell the agent to write a short comment directly at these critical points in the code. And with this same logic, you can track how your business logic changes over time like a changelog, but for your decisions. Tip number 7, make the harness smarter with every repetition. Every edge case you find, note it and generalize it. Keep updating your docs all the time, and the same mistake will never repeat in the future. You can create a learnings MD file, and during every work session, collect the valuable reusable findings there. After we finish some work, we check this file, and if there's something useful, we update our environment with these new discoveries. You should maintain your harness all the time, because if you don't plan for it, you'll never find the time. The main projects you actually work on will always take that time. And the same rule counts for your project documentation. No code change ships without a lookup into the docs, and an update whenever it's necessary. Part 3, protect the agent's memory. Now, one concept you must understand because everything in this part depends on it. Everything your agent sees in one chat, your messages, the files it opened, the answers it gave, all of that lives in something called the context window. Think about it as the agent's short-term memory. And here's the catch. It has a limited size, and the agent starts every new chat completely empty. It remembers nothing from yesterday. So our job is to protect that memory. Keep it clean, keep it small, and put the real memory into files. Tip number 8. Never compact your chat. Agents are the most efficient when they start from scratch. Get the context, get the task, execute. Everything after that starts fading. The agent starts forgetting the stuff we're building in the first place, starts making assumptions about our project rules without even reading them, and the implementation goes into totally the wrong direction. Never fall in love with your chat. You'll get this feeling that the agent understands you better and better. But believe me, that's a dangerous area. When the conversation gets too long and we reach the full context size, the chat gets compacted. In other words, summarized. And from that moment, you only have the feeling that everything is fine. It's not. Details are gone and you don't know which ones. And even before the compaction happens, a long chat keeps fading anyway. So keep your chats as short as possible. One task, one chat. Tip number 9. Spawn helper agents for the research. Sometimes a task needs a lot of context before the real work can start. The agent has to pull data from different resources, from our code base, from the database, from the web, from some endpoint. And if all of that lands in your chat, the context window is full before the implementation even begins. So here's the trick. Instruct your agent to spawn helper agents. Claude Code and Codex have this feature built in, and they call these helpers sub-agents. Your main agent sends a prompt to a helper agent, just like a user would. The helper does all the digging and sends back only a summary of the findings. Your main chat stays clean and healthy, and the research goes several times faster because the helpers work in parallel. But one thing to remember, use the helpers for research only, never for the implementation itself. And the reason is simple. The helpers don't see your full harness, your rules, your docs, your specs, the way your main agent does. So let them gather the knowledge and let the main agent do the building. Tip number 10. Demand detailed commit messages, always. Every time the agent commits code, make it write a detailed commit message. That's the short note that gets saved with every change in Git. You're doing this for your future self because this way the agent can always rebuild the story of the project, what was built, the logic behind it, and in which order it happened. You just tell it, check the GitHub history, the recent changes, and the commits that were made. And now it has in its context your current code, the problem or feature you're working on, and all the past decisions and changes. And you can push this even further with one simple folder structure. For every significant change, you create a new branch on GitHub. And inside of your project, you create a folder called tasks. Inside of that folder, one subfolder per branch with the exact same name as the branch. And in each of these folders, you keep the specs MD files you actually used for that implementation. Now you have the full history of your work, not only on GitHub, but locally too, in files your agent can read in seconds. So if we made a mistake sometime in the past, we have the history of all the fixes we made after that. Tip number 11. Fix a bug that's older than you. If you get a task to fix a bug that was left from the last century and the logic behind it is known only to some senior from that same century, here's how you do it. Open a chat, explain the problem, and tell the agent to retrieve all the context from your harness and then to dig deep into the repository with the Git history. Give it every extra piece of information you know, the owner's GitHub account name, roughly when it was implemented, when we first found out about the bug, literally anything. And then the agent starts its expedition through your repository. It jumps between branches, walks through the implementations in chronological order, and comes back with deep insights that nobody in the company remembers anymore. And there's one big lesson to take from this. How do we prevent bugs like this from repeating? Write tests. Every time, for every single implementation you do. Tests are the fence that stops regressions, breaking one thing while fixing another one. And notice one more thing. This whole trick only works because of the habits from this section. Clean branch names, detailed commit messages, documented code. We're not building the app only for human readability anymore. we're building it for the agents too. We define specs-driven development at the beginning. Plan in a file, execute from the file. Now let me show you how to create these files properly. Tip number 12. Build the spec together with the agent. You are the planner now, but you don't plan alone. Open your agent, write a prompt on what you want to build, and instruct it to first check your project, all the docs and the rules we have there. And then comes the important part. Ask the agent to interview you. Tell it, ask me about every unclear decision, every knowledge gap, everything that looks wrong in my plan. This way, the agent won't blindly follow instructions, and you'll find the holes in your own thinking before any code exists. Then ask it to chunk the full plan into logical units. And a logical unit is a group of work that belongs together. For example, a set of shared components or one endpoint with everything around it. Every unit gets its own checkbox for progress tracking. Then, at the bottom of every specs file, tests. Ask the agent to plan all the necessary tests for the new feature right inside the spec. And one more trick. Instruct it to plan on testing the feature by itself too, with the Chrome DevTools MCP once the building is done. And finally, the output of this whole conversation is stored in your specs.md file ready for implementation. Tip number 13. Define done as something you can see. When you write the spec, decide immediately how the finished thing will be verified. Done must be something observable, a response you can call, a test that passes, a number you can measure. Never accept done as a feeling. Validation is the most critical part of the whole spec. The file must make completely clear where we are now, what we're building, and how the validation looks. And that's why we never forgive a failing test. Not one. If a test fails, the work is not done. That's it. Tests were out of fashion for some period of time, but in this new world, they're one of the most critical parts of the whole machine because they're the fence that lets the agent run fast without breaking things. 100% test coverage is our new standard, and our tests target the implementation from two angles. Code-wise, the logic works correctly, and behavior-wise, the feature does exactly what the user expects. Writing the tests against the spec and the expected behavior is called specs-driven testing. In plain words, the test can only pass if the feature produces the output that users expect. Tip number 14. Implement by logical units, not by list order. One more thing about the items in your spec. We write them in chronological order on purpose so the agent can read the file from top to bottom and understand what we're building. But that doesn't mean the implementation should follow that same order. The agent should always pick the most important unfinished unit. For example, if we're adding a few new pages to a website, it makes no sense to build page 1 completely, then page 2 completely, because the pages share so many reusable components. The smarter way, first build the shared components as one unit. Then, in the next round, build one page from these components and add the new custom pieces where needed. So, the list explains the plan in a logical reading order, and the agent picks the building order by importance. Part 5. The loop. And now the part you've been waiting for. Everything we built so far, the docs, the memory habits, the specs, it all comes together here. This is where your agent starts working alone. Tip number 15. One item, one fresh chat. Here's the base move of the whole loop. You have your specs.md file ready. You open a fresh chat and you instruct the agent. First read the relevant docs and rules files, then open the spec, pick the most important unfinished item and implement it. When it's done, update the documentation, tick the checkbox, commit, and push. And that's it. Then you close that chat, open a new one, and give it the exact same prompt. Of course, if the specs file is short, you can do it in one go, but most times you'll go one by one. And why so strict? Remember the memory part? Every session, the agent is a stranger with only the repo. It knows nothing except what's in the files. So our final goal is to make it as easy as possible for the agent to onboard itself immediately and execute right after that. And I strongly suggest you repeat this manually for some time so you gain confidence in your harness environment. You'll see exactly where the agent gets confused and you'll fix your harness piece by piece. That confidence will pay off in the next tips. Tip number 16. Give the agent a handbrake, the blocked.md file. Sometimes the agent won't be able to finish an item no matter how perfectly the plan is written. For example, it needs to reach some external database through an MCP, and the access doesn't work. It's not the agent's fault, but it's a blocker. And these things can happen at any point of the implementation, less and less over time, but they happen. Now, the worst thing the agent can do in that moment is to start guessing. So we give it a handbrake, a blocked.md file. The rule for the agent is simple. If you hit a real blocker, don't invent anything. Write the problem into the blocked.md file and stop. This file is the signal that we have to jump in. We read it, we fix the real cause by hand, maybe the env variables, maybe some service that lives outside of the project. Then we empty the file and we run the implementation again. This one habit prevents a whole family of disasters where the agent starts assuming data that was never available to it. Tip number 17. Automate the whole thing, the Ralph loop. And now the famous one, the name I asked you to remember. Once you've run the one item, one chat cycle manually and your harness feels solid, you can automate the cycle completely. The idea is very simple. Put the prompt into a file and run the agent in an infinite loop. The original version of this line comes from Jeffrey Huntley, the engineer who made this pattern famous and gave it the name Ralph loop. And it looks like you can see it right there on your screen. And one practical warning so you don't get stuck. The exact command depends on your tool and its version. For Claude Code today, the working form looks like this. And if you use a different CLI, just ask your agent for the exact non-interactive command for your tool. The links about the original Ralph loop are in the description. And inside the prompt.md file, we put our loop prompt, something like this. Read the architecture MD file and the rules in the rules MD file to get context about our project. Then open the specs MD file. Before making any changes, search the code base with parallel subagents. Never assume an item is not already implemented. Then implement the most important unfinished item from the list. When you finish, tick the checkbox, update the docs, commit with a detailed message, and push. Every run of the loop is one fresh agent, one item, one commit. And of course, we define the exit condition. The simplest rule, when there are no unticked checkboxes left in the specs MD file, stop the loop. And that's the Ralph loop. One line of bash and everything else in this video is the harness around this one line. Tip number 18. Recover with git reset and a prompt fix, never by hand. When one iteration goes bad, and sometimes it will, the recovery move is always the same. Git reset hard, which means throw away everything from that bad run and go back to the last good state. Then fix the prompt or the spec or the rules, whatever allowed the failure, so it cannot repeat. And then run the loop again. Never repair the damage by hand. Because whatever you fix by hand today, you'll be fixing by hand again next run and the run after that. Any problem created by AI can be resolved through a better series of prompts. Tip number 19. Give every loop ending its own exit code. Since we're aiming for full automation, we can't sit there and read the agent's logs to figure out what happened. So we predefine the possible endings, the exit statuses, done, blocked, budget, compacted, and after we define these, the flow direction depends completely on them. And we know exactly what happened while we weren't present. If the status is done, we just get notified, nothing to do. If it's blocked, we open the blocked.md file and resolve what's inside. If it's budget, we passed our token limit, so we schedule the run to continue in a few hours. And you can expand this list. For example, a status stuck if there were no commits in multiple iterations, or a status outage if some endpoint keeps failing with API errors. The most important thing is to cover the base endings first and keep improving the list while you use the loop. Tip number 20. Log every iteration into its own file. Every iteration of the loop should write its own log file. The exit codes tell you how a run ended, but when something goes wrong quietly in the middle of the run, the logs are the only way to find out what actually happened and at which point of time the digression was made. And remember our rule. We don't touch the code, we fix the harness and run it again. But without the logs, you can't know what to fix. With them, it's easy. You open a new chat, you explain what the loop does, you point the agent to the relevant part of the code and to this log, and it finds where the run went wrong. These logs will always be a valuable asset when you evaluate your whole harness setup. Tip number 21. Improve the loop from inside the loop. The logs we previously mentioned are also your improvement engine. After every full cycle, we dig into these logs and we feed them to the agent and ask, where did an iteration get stuck? Which instructions were not clear enough? Which items took the longest? And what should we change in the prompt or in the docs? This way, the harness gets smarter after every full pass. The loop literally improves the loop. Tip number 22. Loop everything repetitive, not only the features. The loop is a general engine, not a feature factory. Anything shaped like pick an item, do it, verify it, tick it, fits into it. Test runs, refactors, documentation generation, cleanups, audits, evaluations. A new use case only needs a new prompt file and a new task list because the machinery stays exactly the same. And you'll know you really understood this idea when at least one of your loops does something that is not a feature. Tip number 23. Climb one level at a time. There's a natural ladder in this work, and the critical part is to respect its order. First, you write code manually. Then you work with an agent, chat by chat. Then you run the loop manually, item by item. Then you automate the loop, and only then, many agents and orchestration on top. Every level has its own failure modes, and the level you're on teaches you the failures of the next one. So if you skip levels, you'll meet all of these failures at the same time, unattended, and I really don't recommend that. Master the failure modes of your current level, then move up. Part 6, trust but verify. The loop builds fast, but speed without checking is how disasters happen. So this part is about making the harness verify the work with live feedback, with layered checks, and with reviewer agents. Tip number 24. Close the feedback loop with live logs. When the agent creates a new feature or you want to debug something, the single biggest upgrade is this. Make the agent see the results of its own work immediately. The setup is following. Instruct the agent to write logs in the code, then track these logs with the Chrome DevTools MCP and feed them straight back into the same session. With this approach, your agent is the builder and the QA at the same time. It changes the code, opens the page, reads what happened, and corrects itself. But one important warning, control the size of these logs. Don't let the agent load 10,000 lines into its context window. So we set a rule for it. First, inspect the size of the log, then extract only the necessary piece. And if we still can't tell where the interesting part is, we send the oversized log to a helper agent with one instruction. Find and return only the part that matters. The tokens are still spent, but our main context stays clean and without bloat. And clean context means correct work. Tip number 25. Replicate websites like a pro. We've all been there. The code is clean and correct, but the page in the browser tells a totally different story from the original. The problem usually isn't the code quality, it's what the page actually renders. So when you QA a replicated page, don't trust one signal. Stack your validation into layers. Layer 1, compare the code. It should be identical or equivalent to the original. Layer 2, compare with the Chrome DevTools MCP at every level, element by element, section by section, then the full page, and match the computed styles of each element against the original. Layer 3, pixel accuracy with a pixel diff tool, for example, pixel match, and treat this one as a smoke detector. It shows your agent where to look, but it's never the final judge. Layer 4, instruct the agent to test the page as a real user. Click, scroll, type, and then run all of this across every screen size so everything is 100% responsive. Tip number 26. Schedule reviewer agents in your project. And the last piece of trust, reviews that run without you. Create and automate reviewer agents inside of your project. Different types. One checks the code against your rules. One checks the consistency of the current work against the docs, and one hunts for docs that contradict each other. They run on a schedule, and they retroactively fix all the gaps and regressions we make over time. And everything they can fix safely gets committed and pushed immediately. And for everything else, we add one more file, the reviewer findings MD file, everything that needs our manual intervention and decision, the reviewers write in there. From time to time, we open this file with a fresh agent, investigate the findings, decide what has to change in the code base or in the MD files. And after we finish, we clean the file up and leave it empty for the next scans. Part 7. Running many agents. Everything so far was one agent at a time. And I strongly recommend you to start there and stay there until it feels easy. But when you're ready, here's what the next level looks like. Tip number 27. Make two agents argue about the design. Before the planning starts on a big feature, let two agents argue about the design. One proposes the design, the second one attacks it, finds the weak points, the missing cases, the simpler alternatives. And the design that survives this fight becomes the spec. This works because different perspectives catch different problems, the same reason human design reviews work. So never implement a design that only one context glanced at once. Tip number 28. Choose your shipping mode, one by one or parallel. There are two ways to ship with agents. Sequential, one thing at a time. Plan it, build it, ship it, next. And parallel, several agents working at the same time. One does the refactoring, some of them build new features, and others fix bugs from our support tickets. If you're just getting started, I strongly recommend the sequential mode. And that's the mode this whole video teaches. In sequential mode, the agent works on a branch, exactly like we said in the commit tip, and the flow is simple. One implementation at a time, you review the result yourself and you merge it. No pull requests needed because nothing runs next to it. In parallel mode, every agent creates its own branch for the implementation it plans to make. And instead of merging, it opens a pull request. And that's why parallel mode needs one more agent on top of the repository. Think about it as your most senior developer. It watches the repo, waits for these pull requests, reviews them, writes feedback, and merges them. And what about merge conflicts? Two agents changing the same thing in different ways. That's exactly where this reviewer shows its value. A conflict becomes a decision point. The reviewer sees both solutions, compares the logic from both sides and angles, and picks the better one for our app. Now, we still keep the agents isolated on their own branches, so conflicts stay rare. But when one happens, it gets judged properly instead of merged blindly. Tip number 29. Add a workboard when your loops multiply. Past a few parallel loops, files alone stop being enough. You can't see the whole picture anymore. So the mature pattern adds a board on top. The board watches your work items, turns each one into an isolated, autonomous implementation run. And every run has to land with proof of work. The diff, the passing tests, the evidence. On one screen, you see every run's state, cost, and proof. And note what the authors of these systems say themselves. A good harness is the prerequisite. The board sits on top of good harnesses, never instead of them. The harness will never be a one-time thing that you build and forget. That's why we build it in a generalized way, not glued to one single task. And the way to really understand it is always the same. Use it manually, test it, and keep iterating. And once the system earns your confidence, you look for the patterns that are ready for automation. So from now on, your actual full-time job looks like this. 1, understand your project. 2, understand the ways of building and debugging it. 3, create a reusable harness environment around your project. 4, automate the proven methods and predict the future ones. 5, track the full behavior and improve the system all the time. So, are engineers still needed? 100%? Yes. But we're learning new skills now, and we work differently. The major switch is this: from writing the actual code to creating the environment that writes it for us, we always stay in the driver's seat. We make the decisions, we constantly improve the system, we supervise everything that's being delivered, and we fix all the gaps we experience during the executions. That's it for this video. Make sure to comment, like, and subscribe. Let me know in the comment section if you found something valuable here and ask any questions you have. And if you're interested in a full end-to-end tutorial about this topic, where we set up everything together from zero and cover every corner of harness engineering, tell me in the comments. Your likes and your support are the signal for me to create that full deep dive video. See you all in the next video.